In this video, we will discuss the chain rule for computing the derivative of a composition of two functions. So let's say we have some function f of x, and inside of it we plug in another function g of x. So this operation, when you take one function and plug it into another, is called the composition of these two functions f and g. And let's write this composition as h of x. Then the chain rule is telling us that the derivative of this composition h of x is equal to the derivative of the outside function f, where inside you still keep the function g of x, and then on the outside we multiply by the derivative of this function g of x. So for example, if you take cosine of x and you plug in sine of x inside, then the derivative of this composition will be the derivative of the cosine, which is minus sine, and inside you still keep the sine of x, and then on the outside you multiply by the derivative of sine, which is cosine of x. Now, to see where this chain rule is coming from, let's look at this diagram here, where we take some value of x equals to a, and then when we plug it inside the function g, let's call the output b. And then when we take this output b and plug it inside the function f, let's call the output of the function f c. So the composition of two functions is exactly when you plug some number inside g, and then you will plug this function g inside f. So the composition of these two functions, when you evaluate it at this point a, will give you c. And then let's increase this input slightly by some increment delta a, and then plug it inside g, and after that plug it inside f. Now, since our functions f and g are continuous, when we change the input slightly, this first output will change slightly, let's call it delta b, and then the final output will also change slightly, let's call it delta c. And the derivative of the composition of these two functions is just the rate of change of this final output delta c relative to the original input delta a. And so to compute the derivative, we have to multiply delta c by delta a, and when we let this increment delta a go to 0, this is exactly the definition that in the limit you will get the derivative of this composition at this point a. And now to get this chain rule, what we need to do is simply multiply and divide by this intermediate increment delta b. So you notice here, if you cancel delta b, you get exactly this. So we are not changing anything. But then if you consider these two new factors separately, the first one gives you the rate of change of the output of your function f relative to the input. So when delta b goes to 0, here you will just get the definition of the derivative of this second function f evaluated at this point b. And then when you look at the second factor there, it's just the rate of change of the output of this function g relative to the input. So when you let delta a go to 0, that's just the definition of the derivative of this function g at this point a. And so finally, if you notice that in the first factor here we plug in b, and this b is nothing but g of a. If you replace that b by g of a, you get exactly the chain rule for the derivative of the composition of these two functions f and g.